Okay, then we were studying about the parts of the valve. Basically, three parts: the valve tip, its stem, the valve stem, then comes the valve head, and underneath the head comes the combustion phase or the valve phase. So these are the parts of the valve, and we saw the working of the valve. So how was the working here? The cam lobe touches the follower and the valve is compressed against the force of the spring and it is further opened. So here this is the inlet valve, this is the exhaust valve. Okay, so there are two valves basically present inside the a conventional engine, and in modern days there will be about two inlet valves and two exhaust valves. That is, all in all, there will be four valves in the engine. That is modern technology, but conventionally there is only two types: intake and exhaust valve. Two valves. So you can see here itself, from the figure itself, you can see the bigger valve here is the intake valve and the smaller valve is the exhaust valve. So this is how the valve difference we can see. So the biggest valve we can see here, you can see some big valves here. So bigger valves that you see here are inlet valves, while the smaller ones are the exhaust valves. So we can see what are the difference between inlet and exhaust valve. So inlet valve functions for allowing the air-fuel mixture into the cylinder prior to the compression and ignition. So before the end of compression stroke, that is, the piston moves from top to bottom in the first stroke, that is called the suction stroke, and during that stroke, air and fuel from the intake port enters the cylinder through the inlet valve. It can be named as inlet valve or intake valve. Both are same. So when inlet valve is opened, the air and fuel mixture enters the cylinder and the piston is moving downwards. And when the piston moves upwards, the intake or inlet valve has to be closed. If it is not closed during that compression stroke or during that movement of piston upwards, the air fuel mixture present inside the combustion chamber may escape through the inlet valve itself. So that must not happen. For that purpose, the inlet valve is closed before the compression stroke starts. So it is closed before the combustion stroke starts. It's not observable here. Okay. Then inlet valve are slightly bigger than exhaust valve. So you can see here, this is an exhaust valve and inlet valve. So the bigger valves that are shown here is the inlet valve. Then inlet valve, because of their lower operating temperatures, are typically made up of materials such as chrome, nickel, or tungsten steel. So these are the materials used for the construction of inlet valves. Due to their lower operating temperatures. So what is this lower operating temperatures? So I had told you before, the amount of or the temperature that is obtained at the combustion chamber will be about 200 degrees Celsius when the explosion inside the cylinder happens. So while the suction stroke is happening, the intake valve will be opened. So during opening, the air and fuel mixture that is entering the cylinder will be always cold medium, will be in cold medium. So due to that coldness, the intake valve will not face any temperatures except at its face. So when combustion occurs, the face is exposed inside the combustion chamber. So the face is exposed. So the face is made with another material, which I will discuss later, while The other parts are made up of chrome, nickel, or tungsten steel. Okay, naturally, due to conduction, when temperature inside the cylinder increases, the topmost part or the face of the valve will have the most temperature. Then it may vary upwards because of conduction. So the heat here will be much less, but here there will be more heat because it is in contact with this area. Okay, this will be the hottest area. So still it is colder when compared to exhaust valve. Exhaust valve will be facing the full brunt of the force. Full brunt of the temperature difference, or the temperature, the higher temperature that is generated inside the cylinder, because the exhaust products will be at higher temperature. So while discussing that, I'll explain it. So what are exhaust valves purpose? The exhaust valve open to permit the expulsion of exhaust gas from the combustion process after ignition has occurred. So this is the function of an exhaust valve. It expels the exhaust gases that is formed after the compression process, and it allows the air to the exhaust products to escape. So once the exhaust valve is opened, the piston moves from bottom to top, that is BDC to TDC. Once that movement is done, the piston itself pushes the exhaust products out through the exhaust port. Okay, due to the movement of the piston upwards, the exhaust products are carried out or pushed out from the combustion chamber by the piston through the exhaust port. So at that time, the exhaust valve will be open. So 200 degrees Celsius is the temperature that is present inside the cylinder, and it will reduce to some degrees due to heat conduction and heat losses such and all. But even after that, when the exhaust valve is opened, the exhaust valve faces huge temperature of exhaust products escaping the port. So the exhaust products will be at a higher temperature. Okay. For that purpose, the higher temperature exhaust valve may use more heat resistant metals. So heat resistant metals are used for the construction of exhaust valve. So what are the heat resistant materials? This is a nichrome, silicon chromium, or cobalt chromium alloys. These alloys are heat resistant material. Nichrome is a material that is used in heaters, iron boxes, because due to its a high heat resistance and the generation of heat, it is used in iron boxes and all to generate heat. Okay. For that purposes, nichrome wires are used. So nichrome is the material that will be most commonly used in exhaust valves. And for that purpose, or for so if the if heat resistant metals are not added in the exhaust valve, failure of the exhaust valve will occur and the sealing action of the combustion chamber will be lost. For that purpose, we are using heat resistant metals in exhaust valve. Now, valve faces, even though it is closed, will always be exposed to higher temperature inside the cylinder. So valve faces that are exposed to higher temperatures are made durable by welding of stellite, which is an alloy of cobalt and chromium, to the valve face. So the valve face itself will be made up of another material that is known as stellite, which is welded onto the valve face, and stellite is an alloy of cobalt and chromium. So even higher temperatures are obtained at the valve face. So the valve face is protected by welding stellite to the valve face. both in the exhaust valve and also the intake valve or the inlet valve. So you can see here the basic temperatures. So this is a normal working condition of a valve. So it is not an exhaust valve, it's also not an inlet valve. But when the valve is closed and how the temperature is distributed in a valve, that is shown here. So at the valve seat position or the fillet position, you can see how the temperature differs. So it is 1050 Fahrenheit here. Then on going downwards, 1080 Fahrenheit, uh, 1150 Fahrenheit, but on the stem it will be cooler, that is 800 Fahrenheit. So you can see that the brunt of the temperature will be here. From the center, the most closest point will be here and it will have 1050 degree Fahrenheit, while these points will have 1080 degree Fahrenheit, then 150 degree Fahrenheit. This is a basic temperature. I just want you to show how the temperature is differing across the valve regions. So this stem it will be much cooler. Okay. So I will show you some videos regarding engine head valve and all. Okay, this is a engine head here. So it is a disassembled engine head. He will show you how the valve is arranged inside the engine head. So this is the overhead cam that is present inside the engine. Two such cams will be there, as you can see there will be uh, okay, there will be two sections of valves here. These are valves. These things are the valves that is shown here. And there will be one cam here, one camshaft here, also another camshaft here. So there will be two
Sir.
camshafts. So he has some one, yeah.
Sir, video present ചെയ്യുന്നുണ്ടോ?
Yes. Hello.
Sir, video present ചെയ്യുന്നുണ്ടോ?
കാണുന്നില്ല.
ഇല്ല സർ.
കാണുന്നില്ല. ഓക്കെ ഓക്കെ. അല്ല, വീഡിയോ പ്ലേ ആവുന്നില്ലോ? You can see the video. It's not being played. Now it's playing. You can see it playing.
Yes, sir.
Okay. So, playing. So it's one camshaft, such as one more camshaft is there, and this is the cover that holds the camshaft in place. So the camshaft will be present here on top of this and on top of this. So there will be two camshafts, and you can see the cam lobes here. There will be several lobes here. Then how this is so video is running, you can see, right? Can anyone see the video running?
No, sir.
No. Can you see the video running? Is everyone seeing the video?
Yes, sir.
Yes, sir.
Okay. 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 So he's going to do is called okay, this is called a valve spring compressor, and he's going to remove the from its place. Before the valve has okay. I told you about the valve groove here. So this is a groove. So at this groove, there is a lock nut there. So he'll bring in the lock nut present there, and how he assembles the lock nut, and how the valve is attached to the spring. So he's going to show you that. So for removing the valve, you have to remove the valve or the lock nut inside the valve groove. So he's using a tool that's known as a valve spring compressor. So this is the lock nut present. So you can see a lock nut here. Okay, this is a one half a semicircle. Both are semicircle. Two lock nuts present like this, so that you can remove the two lock nuts. So this is what is holding the valve and the spring together. And this thing that you see here, this thing that you see here is known as the valve cap. So this is the valve cap, and that holds the spring, the lock nut, valve. So that is the function of the valve cap on here. It's going to disassemble the valve. Okay, you can see here the valves here. So the bigger valves are the inlet, and smaller ones are the exhaust. So these are the how valves are present inside the ports. So it can be the inlet or exhaust. You can see here the ports. So these are the ports, and in this you can see the valves that is present here. So this is the valve here, and another valve is here. Two valves are present. See how the valve is seated inside the cylinder. Okay, now he's going to use the valve spring compressor. The tool here is to at this point, the valve face will come into contact. The valve face will be in contact with this point, and this will be the compressor point. This point will come into cap. Okay, this will be at the valve face. This will be at the valve cap. You can see how it is done. So see, he is placing this at the valve face, and you can see he's going to compress it at the. See how the lock nut falls out. So it is present at the lock nut is present at the valve groove, and once he presses the spring compressor, the lock nut ejects out from that groove. So this is lock nut. See, two semicircle lock nuts are present here. So like a bear. So this falls out. And once the lock nut is removed, you, you can easily remove the valve from its position. There is a magnetic tip point, and he removed the lock nut. And when we release the compression in the valve spring compressor, there is a releasing. See, the spring is removed from the valve. Take the spring and valve cap. That's the valve cap that is holding. And then we can remove the valve also. So that is the lock nut. And that is the inlet valve. That will be the bigger valve. So it is the inlet valve. So why the inlet valve is bigger than the exhaust valve? During the motion, okay, during suction stroke, the piston moves up to down, that is from top dead center to bottom dead center. When it moves in that particular fashion, air and fuel enters into the cylinder. Okay, to increase the amount of air and fuel entering the engine, we provide bigger inlet port, also bigger inlet valve. So when we provide that, more amount of air and fuel enters the cylinder. So this facilitates more mixing of fuel with air and giving us a good combustion. So in a good combustion, we will have less smoky exhaust and less combustion byproducts, and we will that is, the byproducts should only be carbon dioxide and water vapor. That is what is known as a clean combustion or a good combustion. So for that to occur, we have to give sufficient amount of air for the fuel to burn properly. So when we increase the volume of air entering inside the cylinder, we will get a clean combustion. So for that purpose, the inlet port will be bigger. So to close that port, a much bigger inlet valve. So a bigger inlet valve is provided for that purpose. And why not for exhaust? So in exhaust case, the piston assists the expansion of the byproducts. The piston moves upwards, thereby pushing out the exhaust. So it does not have to have bigger exhaust port. So the exhaust, even if it is small, it's no problem because the piston assists in removing the exhaust products. Okay, that is why the exhaust valve is smaller when compared to inlet valve. So when you are disassembling the valve again, the valve is first inserted into the cylinder, then the spring and cap is fitted, okay, fitted back into the valve. Then again the same procedure is repeated. Wherein we use the valve spring compressor and compress the valve. We compress the valve and okay, that is that is coming to back for then the valve will stay in place and the valve will not move out. So for that the lock nut should be given. Expose groove that is inside the valve groove here, and the lock nut is placed there. It's for lubrication purposes and all. And also it will stick there. You don't have to just keep it there. So due to the grease present there, it will be placed there. Okay. Okay, it's using different tools for valves. Okay, that's how the valve is assembled and inside the engine. Next. Okay, next I will show you the engine block. So he has already removed the pistons here. So I'll show you how it is assembled back. So what he lifted up now is a gasket. So this is what is a gasket. So a gasket is the thing that acts as a sealant between. So we are connecting the engine head on top of the engine block. So this is the engine block, and we are connecting the engine head above the engine block. So these are both two different parts. So to seal those two parts, we use nut and bolts, but that will not have a airtight uh, airtight fix. So for that purpose, we provide a gasket in between. So we'll put it in between the engine block and engine head, and then we will screw down the engine head to the engine block. So this will act as a sealant so that the air or the combustion products will not escape outside the engine. So that is the gas. That is the oil pump that is case. The oil pump. Okay, you can see here. This is the crankshaft that is placed here. The crankshaft, and this is the crankcase. Okay, this part, the part below the engine block. So engine block is completely, but you can see here it is bolted here. There is a bolt here. So once we remove this bolt, this crankcase will disassemble. Okay, the crankcase can be pulled out from the engine block. So after that only we can remove the crankshaft from the engine. So this has to be removed. So you can see how all the bolts are removed, and once you remove all the bolts, the crankcase will be assembled from the engine block. So this is how he rotates the crankshaft inside. You can see the rotation of the crankshaft here. So he is exposing the cranks where the connecting rod is connected. So for that purpose, he is rotating the crankshaft. So it has to be exposed in this hole. Okay. Once it is exposed here, he stops and then he will try to remove the. You can see here the bolts for that. So the big end of the connecting rod is wedged with those parts. Okay, the crank is exposed here. So we removed that part of the connecting rod. The same way, two more. So this is the piston he is holding of the engine. So he has removed this one, and you can see the piston that is removed here. That is the piston. Once this comes free, this top part comes free, the piston also comes free, and we can remove the piston. And this is the connecting rod he is holding, and below that is the piston. That is how it is seated inside. So this is the cylinder bore exposed here. There is a piston here. You can see a piston here. And in the same way, there is a piston here also, both pistons. So is exposing that parts and is removing each piston. So you can see the piston being removed. That's a piston there. Okay. Two more pistons. And the last piston. That is the last piston. So the piston has been disassembled from the engine block. So this is the cylinder bore and is cleaning the cylinder bore. Okay, the crank is exposed here. Now we have to remove crankshaft so that these bolts are very good. So these bolts are present in the crankshaft bearing journal circle. So these are points where the main journal. So journals hold the crankshaft in place. Journals are points that hold the crankshaft inside in place inside the engine block, so that the crankshaft will not move sideways or in any other irregular ways. But we only need the rotational motion of the crankshaft. Okay, so we had to remove. For removing the crankshaft, we had to remove the bolts, and this is a flywheel case that is inside, and this is a cover that is on here. It's a cover here, and we are removing the cover for exposing the bolt inside. So you can see the oil that is present earlier is present inside the cap itself. So this is how the oil is lubricated inside. So oil must be present in all these parts for sufficient movement of the mechanical parts. The oil is wedged in between the caps also. So you can see once the cap is removed, there will be a bolt here. See, there is a bolt head here. In the same way, there will be a bolt head there. Okay. Now is removing the bolts holding the journals of the crankshaft. Okay, crankcase from that point. So is removing the crankcase. See, the crankcase is removed, and this is the crankshaft that is present here. So the crankshaft is here, crank pins for each cylinder. Main journals also are present. Main journals, holes. These are the holes for lubricating the crankshaft, and also at the crank pins also there will be holes for lubricating the connecting rod. So these points are the journals here. So this is shown. So this point will not move. The moving point is only the crank pin. The crank pin only moves. While the journals will stay in position. See, the journal stay in position. Okay, this is a assembled crankshaft, and you can see these are the journals here. Main bearing journal, main bearing journal, main bearing journal, and the main bearing journal. This is the crank pin. So there will be 4 crank pins because there are 4 pistons. Okay, these are the once the crankshaft is removed, these are the bearings inside the crankshaft. So bearings are also provided in the crankshaft. These are the bearings here, and the bearings are also removed. So you can see the bearings are the only things that is out here, and crankshaft will be present. But, there is no seat bearing out. An additional bearing holder. So there is a holding, the bearings are holded in place. The bearings will not slide outwards. Is cleaning the engine block completely and then only disassembling. So Okay. Okay. Couple of comes the pistons. So you can see the piston with connecting rod here. The connecting rod is attached here, and this is the piston. The piston rings attached. So there is two piston compression rings and one oil ring. And you can see the bearing here itself. Again, the bearing here. You can see the bearing. So the bearing was attached to the so these two bearings here that is present inside the big connecting rod is attached to the crank pin, while also bearings are provided at the piston pin. So we remove it, we can see that. Okay, see, you can see a clear shot of the bearings present inside here. So that is the bearings. So you can see the bearing inside. This is the gudgeon pin that is here. There will be a gudgeon pin that is holding the piston to the small end of the connecting rod. And you can see the oil ring and the compression rings here. This is a compression ring here. And the oil ring is exposed here a little. So that is the two oil rings and one center ring for scraping out and making the oil hole. Okay. So I'm showing you how it is assembled back into the engine. So that is the compression ring here. See, the compression ring is here, and it is a split ring. You can see the split here, and also another compression ring, and then comes the oil ring. But it will not be inserted like this. If you try the free hand, it cannot be inserted. We'll use a tool for that. Okay, see the bearing slot that is provided there. That is again the crankshaft. The bearings are placed back inside. See, the bearings are present here also. When outside where the crankshaft meets the flywheel, and also the sprocket wheel that is outside the crankshaft. So this place also is bared. So you can see the bearing here. There is two bearings here. Okay, so lubricating the surface bearing first by applying lubricating oil, we can add both. And after that, we set the piston and connecting rod is clamped. The tying pins are cleaned and journals. Now, the surface of the bearings, we will place the crankshaft. So he's placing the crankshaft inside the engine. We can see how he's placing it. So the main bearing journals are placed there. That is a side that helps to keep this bearing in place. So there will be no sideway motion of or the linear motion of the crankshaft. So he is trying to seat the crankshaft with the main bearing journals. First, the sharp end of the cutting rod is connected there, and the bolts will be exposed underneath the crankshaft shown here. Okay, this is the connecting rod piston arrangement with also the bearings. Okay, you can see he's measuring the piston ring here. So the piston ring is first inserted inside the cylinder bore. So you can see here. So how it will compressed inside. So this is splitting. Once it is compressed, it will be placed in such manner. Okay. Even there is a small gap there where he has demonstrated earlier. So there is a small gap there. And this is measured tool that is in his hand that is known as a field gauge. So this is a split ring compression ring. And that is an oil ring. So you can see so many split holes here. The holes here, that's the oil ring. This is the compression ring. And see there is also a mark here. Is a split ring itself, so it is having a small gap there. And this is the oil ring. Okay, this is a piston ring expander. So to insert the piston ring inside the cylinder grooves, we use a tool known as piston ring expander. So it expands the piston ring, and then when we are giving, we have sufficient expansion, the ring is then fitted into the piston groove. So it is, he's trying it by hand itself. So we can use the tool also, it's called a piston expander, and we use to expand the string and then place the piston in the grooves provided in the piston. So you can see the seating of the piston. It is showing us the oil control ring here. So it will be a two-part ring, a split ring with the oil part or the oil scraping medium in between. Then comes the second ring, that is the middle compression ring, and then the top compression ring. So these rings are placed here. It's lubricating the surface of the piston before placing the rings. In the same way, he's lubricating the inside of the cylinder bore before it is assembled into the engine. So the crankshaft is already fitted. Now we have to fit the uh, connecting rod and the piston inside the cylinder. You can see how he places the piston rings. So if there is multiple rings, this is how he places it. If there is only two rings, the split ring here, there will be a split, and this split will be present at the opposite side. That is the direct opposite side. But there will be three, if there is three compression rings, then it will be placed in this manner. So it will be in a triangular shape, the split rings will be provided. So this is two split rings. So two split rings will be present like this. Then if another one comes again, we will place it in opposite direction. Okay. One minute, I'm facing some problems. Okay. So once the rings are compressed inside, he can insert the piston back into the. So he's compressing it and then inserting the piston back into the cylinder block. Okay, we'll use another tool also for this purpose. Is shown as a manual way. We also use another tool. It's a piston ring compressor, and with using that itself also we can compress the piston ring and insert the piston. And once the connecting rod is exposed at the the crank pin, then we are attaching the large end to the, we are securing the large end part of the connecting rod with the crank pin. Okay, you can see them connecting it back. Okay. So we mainly saw the cylinder block and the engine working. So this is the flywheel here. This is the flywheel that is shown here. Connected to the engine. So this is how the piston moves inside the cylinder with the crankshaft rotating. And you can see this is the ports that is formed here. The ports are here. Okay. Six engine, so there will be six inlet. Okay, so this is the exhaust. This is where the exhaust will be carried out. Flywheel rotating, and when the flywheel is disassembled, you can see a gear running here. It can also function for the camshaft. Okay, for running the camshaft, and in this arrangement it is called side camshaft, wherein a camshaft will be provided here and a follower will be here, a rod will be present here that will then push the valve, opening and closing of the valve. So a rod will be present here at the camshaft, and this rod facilitates the movement of opening the valves. So you can see how the piston moves here. Different strokes are present here. It is a 6-cylinder engine. Is the water coolant present? The coolant where the water will be flowing inside the engine, This is the oil. So at the bottom of the crankcase, you can see this is the oil sump. It's a case where oil is stored inside the engine, and this oil is traveling in this position. So this is the oil traveling pathways, and you can see how the oil is traveling here at the connecting rod points, the crankshaft, and even the camshaft. You can see the camshaft lines here, and even it goes upwards in the engine head portion. So this is how the oil part is moving. This is the oil pump that is provided here. The oil pump pressurize the oil inside the oil lines and inside the oil sump, and then supply it to the oil in and I have to show you so many holes in the bearings, in the piston, in the connecting rod, such and such. So these holes are holes that the oil can easily flow through these holes and lubricate the piston, connecting rod, etc. You can see how the oil is transferred here. The oil is present inside the piston itself. So you can see how it is sprayed up to the piston. So there's a spray of oil film falling into the piston, and underneath the piston it is lubricated. And this this spraying also affects the oil ring inside the piston. So this spraying will facilitate the oil to be present at the cylinder walls, and when the piston comes downwards, the oil ring that is present inside the piston scrapes off the oil and collects it and drops it downwards. So this film you can see that is dropping downwards is the oil that is leaked out from the piston, or that is falling down by the oil ring present inside the piston. So this is how the oil is moving here. One more. So I have told you about the conventional single overhead camshaft. This is single overhead camshaft, and this is double overhead camshaft. So we are showing the difference. So a single overhead camshaft has a single camshaft wherein all valves are operated by the single camshaft. So you can see here the single camshaft, and this assembly here, the valve and all is there, the valve spring and the valve cap is shown here, and then you can see an assembly here. This is called a rocker arm. So it is called a rocker arm, which acts as a seesaw. So you have seen in the same way itself, a rocker arm functions. So how it is done is the once the cam lobe touches one part of this seesaw or the rocker arm, a pressure force is applied. This force in turn compresses the spring, thereby open the valve. So you can see how that compressing and how the valve is opening here. This is how it is done. And this is a dual overhead camshaft, wherein two overhead camshafts controls one camshaft inlet and other controls exhaust valve. So you can see these are the inlet valves here, these are the exhaust valve, and single camshaft is provided. And this single camshaft will facilitate the opening of opening and closing of the exhaust valve and inlet valve. So you can see how it works here. Then dual overhead camshafts, wherein two camshafts are provided. I can see inlet valves and exhaust valves are there, and it is directly mounted on top of the valves. Okay, this is the present technology that we are seeing. Single overhead cams are replaced by dual overhead cams. You can see how it is. So this is the general working of the cams. This is not a single cam. This is two cams shown. So for opening of the valves, so one can only operate the three valves here. So you can see this is the cam shaft. So there will be another cam here for this one, and one cam for this valve. So there are two valves here. It is not a single valve, a cam that is shown like this. There will be two cams here to operate these two valves. But here in this case, there are two cams, and these two cams are present in two different shafts. This is a comparison between these both. So this is the end of that session. So if you doubt regarding this, then please contact me. So you can ask questions. So we'll be then in the next class onwards, we'll be moving on to an entirely different session. So this is the basic parts of the engine and the engine side. If you have any doubts, you can ask now. Okay, I hope it is clear. Then I will wind up today's class, and I'll take the attendance now. Advait deke.
Present, sir.
Is Advait present? Ah. Advait present, right?
Yes, sir.
Ajay Krishna. Okay.
Present, sir.
Ajay Krishna. Agil K.
Present, sir.
Okay. Ashay Krishna.
Present,
Akshay
sir.
Krishna. Akshay Krishna T.
Present, sir. Present, sir.
Akshay. Okay. Akshay Rajivan.
Present, sir.
Amarnath P.
Present, sir.
Clint Frederick.
Present, sir.
Diljit Suresh. Diljit Suresh. Gokul Gadharan,
Present, sir.
Jishnu Dilip,
Present, sir.
Joel Tom Babu,
Present, sir.
Junaid AP,
Present, sir. Present, sir.
Minosh K. Okay. Minosh K. Is Minosh present? Minosh K. Okay.
Sir, message.
So in the chat
Yes,
box.
Sir.
I see. Okay. Mohammed Sinan,
Present, sir.
Niket Mohanan,
Present, sir.
Pranav K. Pranav N.
Present, sir.
Ritvik M.
Present, sir.
Sharath KV.
Present, sir.
Srinath K.
Present, sir.
Srirag PV.
Present, sir.
Sulabh P.
Present, sir.
Yadukrishnan K.
Present, sir.
Yadul Harish.
Present, sir.
Arun Raj.
Present, sir.
Jishnu KV.
Present, sir.
Jishnu Sajeevan.
Present, sir.
Neeraj K.
Present, sir.
Renish K.
Present, sir.
Vaishak C.
Present, sir.
Gokul Muralidharan.
Present, sir.
Okay. Then we'll see the rest in the next class. Okay, then thank you. You can leave.